new episode of this YouTube Live. I am Raj. Let's wait. Okay, hello everyone, good evening. I am Raj. Welcome to another episode of this YouTube Live from TAN 90. I am a STEM educator and content developer here. So we will start in a minute. Let's wait for some person to join. Uh, I guess we have seen multiple videos on how a transistor works as a switch and also as a amplifier. So today we will be using this NPN transistor, which is BC547, and using this we will create the basic gates. So can you name the basic gates in the chat box? The basic gates in electronics, can you name them? Hi Meghashri. Hi Almas. Good evening. So my question is, can you name the basic gates that we use in electronics? Hi Suryavanshi. Hi Amit. Hi Shrinjita. And or a not get. Okay. Can you tell me the functions of these gates? Anyone, any idea about the function of these gates? And or a not. Correct, Almas. Okay, so these gates are used for many different purposes, even inside a microprocessor or inside a CPU processor. You will see these gates arranged in some manner which will be giving you some output. So today's purpose is we will be creating these gates, the basic gates, and after that in any other video or any other session we will be also creating a flip-flop so that we can save the data that or store the data. So I have a transistor. This is called BC547. This is a NPN transistor. That means this is N pin, this is positive pin, and this is also negative pin. Negative, positive, and negative. So you can also check which pins are called emitter, collector, and the base. So here base is this one. Okay, I'll just quickly flip my camera so that it will be easy for you to see the entire setup. Just give me a second. Okay, sorry for the delay. So this is the transistor I was talking about. This is the BC547 NPN transistor. So we will be using this for creating the circuit. So first I will take this transistor, and this is since the base, I will need a small current here. So what I will do, I will take a resistor and just solder the resistor over here. So I am using a 10 kilo ohm resistor. You can see the color code as well. Okay. Okay, one part is solder. I don't want this much long wire, so what I will do, I'll just cut the extra portion. So here we go. Now we will add a switch. So I am going to use a button switch. So it has 4 pins. The correct way to connect this in a circuit is you can add it in cross. So one side the input can be there and the other side the output can be there. It should not go like this or like this, because these two pins, or might be these two pins, will be connected to each other. It depends on this lines. If you will be able to see, it is might not be visible, but these two lines are connected internally and these two as well. So that's why if you connect here, the other pin will give you the output. If you connect here, the other pin will give you the output. So I'm just going to make the connection in cross. So I'll take this. I'm adding the resistor to the one of the pin. This is done. So now I will add the pin here. This is the working pin. So with all the transistors and all the gates, we will actually need 5 transistors, 5 resistors of 10 kilo ohm, and 5 button switches for creating 3 gates. So I already have done the soldering so that it will save our time and effort. So these are 2, 3, 4 and 5. If you see, all of them have everything in common. If you neglect the length, this one doesn't has a button switch, so I'll just quickly add that. So here we go. Yes. So again the same logic, we will be adding this in cross. So one pin will go here, maybe we can solder it here. Done. Can you see, all of them have everything in common. So I have connected each of them to the base of the transistor. I guess this step is not much difficult for you, you might have done it. Clear? Okay, let's proceed. Now we want to create gates. So we know about the circuits. First one is actually the simple circuit, correct, in which only one LED is present, or maybe one bulb is present connected to the battery or the power supply. The other one is series connection and the parallel connection. So what is my idea? I'll take two of the transistor and connect them in series. One I will keep it as like separate. This is separate, like simple circuit. These two I will connect in series. So I will connect the emitter of one of the transistor to the collector of the second. The emitter of first to the collector of second. This is series. These two I will take, I will connect them in parallel. So emitter and emitter together, collector and collector shouldered together. Clear? Okay. So first I will make the series connection. See, these two are now in series. Okay. One more thing, it might not be visible because this transistor is very small. The both of the front side of the transistors are towards the camera right now. It is not opposite. Can you see? It is not like this manner. It is in front. So one of the emitter is connected to the other collector. Now I will do the parallel connection. For this, I'll connect them in this manner, like this and this. Okay. So it is going to be a little tricky because the pins actually move very quickly from here to there. Okay. one side has been done, the other side I will just secure. It is going to be now the emitters of both the transistor and the collector of both the transistors are soldered together. Make sure this happens properly and both the bases do not touch each other. So I will just separate them. You can see both the sides are now connected properly and they are not separated, not getting separated easily. Okay, my purse is now defined. So these two circuits I have done. This one will be separate. So let's create the first one. So I'll start with the series one. Now since this is the in the transistor, this is the negative, this is the positive, the base, and this is also negative part. I will take a battery clip and peel off its ends. So this is the battery clip. Black wire can represent the negative. So I will take this, I'll connect it over here. Okay, and these are the positive, so I have to make positive connections here and here. Again remember, since the resistors are connected to one of the pins, we will connect in cross. So if the resistor is here, we will connect the red wire over here. ठीक है, इसको कनेक्ट करते हैं. आई होप आप लोग फॉलो कर पा रहे हैं अच्छे से. So this another wire I have. So first I will solder these two together along with this pin because I am connecting in cross. So yes, here we go. Okay, let's do a soldering. Let's check the strength. Okay, this is very good. I'll take another wire because we will need for the LED as well. I will join them together. I'll again do the soldering. Over here, since again this line is this resistor is connected to that pin, to the right one, so I have to make a cross connection. So I will connect here, right there. I guess you are able to view the logic and the sequence I am connecting, correct? Okay, so I am left with this portion and this pin together. Got it? So I'll take a LED. Now I'll take the LED. For saving the time, I have already connected a 1 kilo ohm resistor. This is 1 kilo ohm, this is 10 kilo ohm. 1 kilo ohm resistor to the LED, to the negative part of the LED, just to save the LED solid. Okay, I'll just make a small bend. I'll wrap the wire and this is done. Okay, everything is solid and good in condition. This one is done. So this is one of the gate we have created. We will check out how this gate work functions, and we will also identify which gate this represent, AND gate, OR gate, and not, or NOT gate. Can anybody tell me? Can anyone just make a guess? What is this gate? AND gate, NOT gate, or OR gate? Just put your comment in the chat box. No idea? You can even write no idea. Let's keep it separate. We'll start again with the second one. These two transistors are now connected in parallel. So this again the same logic. Since this is a NPN transistor, so I have to connect the negative pin, the right side pin, this one, with the negative wire. So again I'll take another battery clip. This is the negative portion, so I have to do a soldering here or make the connection here. So I'll wrap around and quickly do the soldering. Good. Okay. Yes, they are good. Separated. The bases are separated and not touching each other as we want. I'll take another wires and then connect them together. So I will join first two wires together. On the other side I will join with it with the battery clip wire, the red one. I have two joints now, so let's see how I'm going to connect. Again, cross connection. So this resistor connected to the leftmost pin at the corner, so towards the opposite side, like a X, I have to connect it over here. Okay. So you can see one is done. The second one I'll connect. So first I'll check where to connect. Okay. So this one. No, not done yet. Now it's done. Okay. This wire again I have left for the LED. Here again we have to connect LED. So this is the LED. This is the negative part. So I'll connect it to the collector of the transistor. This end is left. I'll wrap around the wire and do the connection. Done. Now two of the gates are completed. Can you just make a guess which of the gates are these? AND gate, OR gate, or NOT gate? Just put a comment. Okay, let's proceed to the last gate. So this is the transistor which doesn't have a series or parallel connection. This is just a separate one. Okay, so here the challenge is actually a little, the connection will be a little different. So here first I have to connect the negative here. I'll do that. One tricky thing is here, so I'll take the LED and the negative pin I will take, I will connect it directly to this portion. So I'll quickly make that connection. Not yet done. It take a little bit paste. Solid. Okay. To the other pin, I have to first connect the register. So I will do the register connection at first. I guess this needs a little bit more proper connection. So just a little bit more soldering paste, soldering wire. Okay, done. I'll connect a resistor over here. So I'm again going to take, here I'm going to take the 10 kilo ohm resistor. Similar to this one. So I'll just cut the wire and make it shorter. Now I have to give the positive connection. So I will connect the positive here at the cross. From here again one more wire I will connect here. So I will do the connection of two wires together first. Like this. And the other side I'll connect to the registers. Now can you see? Okay, so all the connections we have done. Just clean the table before we start the demonstration. I'll flip the paper. Now let's see. So these are the three gates we have created. Just give me a second, guys. Okay, so I will take a battery and we will see the demonstration. So I'll connect the battery first here and I'll draw a truth table. So this is A. So this is A and this is B, and we are going to get the output as the LED. So this is the output. So this is the first connection. This is A, this is B, and this will give us the output. Now let's see. Now both the switches are closed. I'm not touching any of them. I'm not pushing them. So both A and B are 0. What is the output? What is the output now? 0. Okay. Now I'll press this one, I'll keep like this. The other one I am going to press. So whenever I am pressing it, it's going to be 1. So this is 0, A is 0, B is 1. So B is 1. I am pressing it. Can you hear the click sound? What is the output? 0. Clear? Now I will press the first one but not the second. What is the output? 0. I will press both of the switches now. So this is 1 and this is the second. What can you observe now? Can you see the output? Okay. So we are getting an output. So this is 1. This is one of the truth table. So which gate it represent? Just put a comment. Which gate, and or not? Hi Devraj, can you just make a guess? Which gate is this? AND gate or not gate? Okay. Let's proceed to the second one. Now I will take the other gate. This is the second one. Do you know, here we had connected the two transistors in parallel to each other. Again, I'll draw the truth table. So this is A, B, and the output. Both are right now at 0. No output? No. I will press A but not the B. So I'll press A. Can you see there is an output? Yes. So when I press A but not the B, the output is 1. Now I'll press the second one, which is B but not A. Am I still getting an output? Yes. I will press both the inputs. I'm still getting an output, correct? So this is 1, 1. This is input and the output is, 1. Can you see? Now can you make a guess which gate is this one and which gate is this one? AND gate or not gate? Let's move to the last one. So oh, this is already on. The moment I connected, this give me an output. So this is A because we have just one input over here, and we will only have one output because one LED is there. So now I am not touching the switches or anything. Still I am getting a output. That means the LED is on. So this is 0. Still the output is 1. I will press now. Oh, so this is interesting. When I am pressing it, it is off. So this for 1, the output is becoming 0. Correct? So what do you think? What gates are these? So this is with gate. The last one is not gate. Correct. It is inverting the signal. Okay. The second one, top one. This is AND gate. Correct, Devraj. Thank you very much. Anybody else who wants to try? And this is OR gate. So how these are functioning? I'll just come to that. For very long, we have showed you multiple different connections in which we had talked about this transistor as a switch. Here if you see, we have just short circuited the LED with the red and the positive, and in between that there is a transistor. So this transistor is acting as a switch. The moment I'll make the connection here, the LED is on because it is in between the positive and negative. But when I press this, the current takes this one, which is the least resistance part, and the current flows directly through the transistor, and the LED actually stop blinking. For the second, in this both the transistors are in parallel. Whenever I press any of the button or any of the switches, either the current goes through the first transistor or the second transistor, and the bulb actually glows up. So this is OR gate. And for the third, the necessary condition is, since this is also a switch, this is also a switch, both switches should be on or connected or complete the circuit so that the LED will glow. If one is not on, this LED is not going to blink at all. Got it? Now, so this is a basic application of transistors where we have utilized the property of transistor acting as a switch. And we have converted it to the gates. Now can you tell me, how can you connect two of the gates together? Like this is the AND gate and this is the NOT gate, so that you ultimately get a NAND gate. NAND, NAND. And how will you make a connection such that this is OR gate and this is the NOT gate, so that if you combine these two concepts together, how will you get a NOR gate? NOR, NOR gate. So this is the challenge for you. Done? Okay. Just give me a second. Okay, so I hope you enjoyed this session. I hope you have learned something new today, and you will also take this circuits to your classrooms and also discuss about the same things in your classrooms. Spark curiosity among the students so that they will be interested in knowing and learning more about these kind of things. It will help them to also build the circuit and see how the things actually function around them. Maybe they can open up some boxes and see how different transistors are there through which all the circuit elements we actually are dependent on. So I hope this session was very helpful and you enjoyed it. Thank you for participating and have a good evening. Thank you. Bye bye.